Hello, my name is Jay Wilson, and I'm the Director of Generation and Stewardship at the Canadian Electricity Association. Today on the Futures Now series, we're chatting about a project from ENMAX that optimized reclaimed wastewater for power generation. Welcome, Jason and Shulamit from ENMAX. Jason, can you tell us a little bit about what's going on at ENMAX's Shepard Energy Centre?
Yeah, so Shepard Energy Centre is Western Canada's largest combined cycle plant. It's a Mitsubishi 501G 2-on-1 combined cycle plant. It's got an output of about 860 megawatts. And ENMAX, you can imagine a plant that size uses a lot of water. When the plant was designed, one of the key aspects of the design of the plant was the use of reclaimed water from the Bonnybrook Wastewater treatment plant here in Calgary. So that's one of the plants in Calgary that treats domestic water that's sewered, and the effluent from the plant would typically go to the Bow River. And when Shepard was designed, we built a pipeline from the wastewater treatment facility to our plant, and we used the wastewater from the effluent, I guess, from Bonnybrook for all of our process requirements. So that's for our cooling water, and then we create demineralized water from this effluent as well.
That's really interesting. So how does using wastewater instead of fresh water benefit ENMAX, benefit your operations, and also are there community benefits as well for that?
For sure, yeah. I mean, there's several aspects to several benefits to using wastewater. So one is just, the reduced water use. A plant like Shepard uses, as I say, a significant amount of water. We use 5 to 6 million cubic meters of water a year. So that's a significant amount of water. And if we can take that from a source like Bonnybrook and reuse it instead of using fresh water, those benefits extend downstream as well, because the fresh water from the Bow River is used by agricultural users, recreational users. So those benefits extend well beyond just Calgary. The other benefit we have as well is by using and optimizing our water, which is Shulamit's going to talk a little bit about that. We have reduced how much we send back to the wastewater treatment facility. So that's another benefit, is we've optimized the use of our water, so we use it more often, if you will, through our process, so that we don't put more into the sewer. So we've reduced our volumes that we would send back to Bonnybrook or back to the wastewater treatment facility by up to 30% annually, due to the optimization work that we've implemented.
That's fantastic. So I think everybody can get behind lowering your water footprint. That you're returning to the wastewater treatment by 30%. But I'm sure that it's not that easy to do in practice. So Shulamit, can you tell me a little bit about what the biggest challenge that your team had to overcome for this project when it comes to achieving that level of performance?
Sure. Okay. So there are really two parts to this question, I think. First of all, we need to cover that there are problems with using reclaimed water altogether, which you wouldn't encounter with fresh water. Among others, I could go on about this for a long time. One of them is the fact that the chemistry is very, very variable. So you can, it'll vary with the time of year. It'll vary even day by day. We have operators that will swear that after every snowstorm, our chlorides will go up. And secondly, it will have a larger proportion of various compounds, organic and inorganic compounds than fresh water would have, and we have to respond to that. And the second part of this that makes this difficult is the fact that we needed to optimize it. And one of the only levers that we have is in adjusting the amount of blowdown that we have. So the way Shepard works from a water standpoint is that we will take most of our water and use it inside the cooling circuit, which are the large cooling towers that you'd be able to see. And a smaller proportion we use for boiler feed water. And every time the water pours over the cooling towers, it loses in its quality. So water will go over the top, and then some will evaporate, and then the remainder of whatever compounds are in there will become more and more concentrated, and after a while it'll become unusable. So we found ourselves that we have to adjust to all these differences. And the way that we do this is by changing the amount of blowdown or the amount of wastewater that we send out. And it becomes a very delicate balance between keeping your water quality, but also keeping your volume of water low. And one of the key challenges that we had at the beginning of this project is we discovered that some of the very methods for testing for some of these compounds were in fact unreliable, and that these were being affected by the very chemistry that the water has and all these complex compounds that it has in it. And what we found was with a particular class of chemicals called disinfection byproducts. And these form from a reaction between the organics in the water and the large amount of disinfectant that we have to use. And we sent this for analysis at an accredited lab, and we discovered that 3 different labs were giving us 3 completely different results. And we had to narrow in as to why this was happening. And the more we thought about it and the more detailed questions that we asked, we discovered that in fact they were using slightly different approaches to how they prepared their samples. And that those ones that, in some cases, when they were applying heat to the samples, we discovered that it was causing some of these reactions to accelerate. And when they accelerated, it was producing a false high result. And so this clued us into the fact that we're dealing with some very, very special water here, that water isn't just water, We've got a fairly complex system over here, and this supported us having to do more research into how these reactions form, how they affect our system, and what it is that we can do to slow them down. And this is very, very important work, because as water sources in this world, as they become more and more precious and as they diminish, I think that more and more industry is going to start focusing on using alternate sources, just like we did. And in doing so, some of this information will be very, very important to bring out there so that other people know some of these challenges and will be able to handle them.
That's really interesting. So this was really something new that is clearly not very easy. So congratulations on being able to pull this kind of innovation off. So Jason, can you see this kind of innovation being used elsewhere, even outside of the province, perhaps?
Absolutely. The sampling techniques that Shulam talked about and the water chemistry approaches that we're perfecting at Shepard can benefit not only combined cycle plants, but really any large user of water in an industrial process anywhere. So, I think there's a lot of application for this. We see that water is a precious resource, and anything we can do to make better use of water, I think we'd like to see that applied everywhere it can be.
Well, I think that's a great way to tie this up. Using less water at your own to make low emitting electricity, using that same technology to help other people lower their own water use potentially, I think that's fantastic. And if there's one last question we want to cover, and this one is so. What is one word that you would use to describe electricity, Jason?
Essential. Electricity is the foundation for our modern world, and without it, I can't imagine the world being as it is today.
Great. And Shulamit, what is one word that you would use to describe electricity?
I couldn't narrow it down to one word, so I decided that electricity is the backbone of our society. Without it, nothing else happens.
Oh, perfect. I think that's a great way to end it off. Essential backbone of society. Thanks very much, Jason and Shulamit.
Thank you.